In this video, we're going to continue talking about confidence intervals. More specifically, about large sample confidence interval for population proportions. This is part 2 of that section. Choosing a sample size. Before collecting any data, an investigator may wish to determine a sample size needed to achieve a certain bound on error estimation. The bound on error estimation for a 95% confidence interval is B, capital B, equals 1.96 times the square root of P times 1 minus P divided by N, which is the standard deviation of our sampling distribution of P hat. Now, if we solve this for N, to do a little algebra here, we get N equals P times the quantity 1 minus P times 1.96 divided by B, quantity squared. Now, what value should be used for the unknown value P? Sometimes it's feasible to perform a preliminary study to estimate the value for P. In other cases, prior knowledge may suggest a reasonable estimate for P. If there's no prior knowledge and a preliminary study is not feasible, then the conservative estimate for P is 0.5. So I know what you're thinking. Why is the conservative estimate for P 0.5? Well, if we were to plug that in, so if we did our P times 1 minus P, and our P was 0.1, that would give us a value of 0.09. If P was 0.2, we would have a value of 0.16. If P was a value of 0.3, we would have 0.21. If P was a value of 0.4, we would have 0.25. And if P was a value of 0.5, we would have a value of 0.25. So basically, by using 0.5 for P, we are using the largest value for P times 1 minus P in our calculations. Let's look at an example. In spite of the potential safety hazards, some people would like to have an internet connection in their car. Determine the sample size required to estimate the proportion of adult Americans who would like an internet connection in their car to within 0.03 with a 95% confidence interval. This is the value for the bound on error estimate B. So what value should be used for P? I think we should go a little conservative here. Let's use our 0.5. So that tells us that P times 1 minus P, when P is 0.5, is 0.25. So we'll plug in those values. So we have N equals 0.25 times 1.96 divided by 0.03, quantity squared, which is going to give us a value of 1067.111. Can't really have 0.111 of a person, so you always round the sample size up to the next whole number. So here we would have a sample size of 1068 people. And that's how you determine your sample size.